Anyway. You want the G4? Yeah.
In a meeting. Okay. See you later. Okay. Love you. Bye, love. Bye. Bye.
Right, folks, very good evening. Hello. Hello. See, we have a packed audience, which is good. Yeah. In fact, I think there's more from Bury than there is from home.
It's all very good. And a packed Zoom.
Hey?
And a packed Zoom.
And a packed Zoom.
Does that mean 3 more?
I think it's more than that, isn't it, Gary?
I heard Linda's dulcet tones there just before.
Oh, yes, that's me. I'm here.
Yay!
Checking on us, Islanders.
Oh, I am. Got my spies out.
There's 10 on the moment.
What, on Zoom? Yeah. Is there?
Yeah. 3v3 plus 1. Somebody's got on Zoom. No, it's 10.
Wow. It must be a record, that.
You have to come again, Alan.
Yeah. You know, for next week.
We might not be saying that in 20 minutes. That's something that told us this lockdown.
Right, we've got some visitors. Good evening.
Evening.
Name and
Yeah, Chris G4ADN.
thank you, Chris. Visitors. Yes, sir.
Ian G7PAV.
Thanks for you. Good. And we have that's good. Tonight, Alan, G4FZP. Oh, I better say, before we kick off, we've had a letter from the secretary, haven't we? And it wasn't us.
No.
If you do have to go to the loo, just leave it as you find it, because apparently there was all kinds of toilet roll and all that, and it wasn't the day we were in anyway.
It was a Wednesday, Tuesday or Wednesday.
But I've just been in there and the blooming toilet roll holder thing's hanging down, so I've pushed it back up again. So there's obviously some.
Hope you filled in the incident book. So you did that.
Well, I haven't. But
Well, you should do it.
Yeah.
Otherwise, we'll get stung for it.
No.
What you need to do, Richard, you should take a photograph of it and post it to her back.
If we have to do that sort of thing, then it's time to pack it in.
Yeah, I suppose so, but she's been a bit picky, isn't she?
She is a bit. Anyway, welcome to everybody. We have Alan, G4FZP from Bury, who's going to do us down to the earth, grounding and bonding in the handshaft. Looking forward to this. Yeah. Take it away, Alan.
Okay. Should I stand up or will that?
That's fine.
Stay here?
Yeah.
Okay, I'll stay here. Ooh, it's like a cinema, isn't it? Well, okay, good evening, everybody. I wasn't expecting to be coming doing this, but Alan nobbled me a couple of weeks ago at the pub saying, Bolton haven't got anything on for this evening. Can you come and do a talk? So I said, well, I suppose so. So here I am. I asked your illustrious chairman which of the talks that I've done before he'd like, and he chose this one. So hopefully it'll be relevant to you. I suppose I better introduce myself, I guess. I'm Alan G4FZP, as you've heard. I'm over in Whitefield. Probably can't work most of you from where I am due to the granite in between us. But I started off in my student days messing about with amateur radio, got a job in the BBC as a transmitter engineer, did that for about 5.5 years, left that due to a lot of messing around. That was about the kind of time when the BBC got rid of transmitters anyway and outsourced everything. So I got out just in time, really. Then I went into technical authorship, then I went into IT, and then eventually I got to retire because they were giving people the push. So I put my hand up, volunteered for VR, and it's the best thing I ever did, actually, because I've actually got time to play radio now. And not really done much amateur radio for quite a while. As you probably know, you get married, you have children, you sell your gear, you have other priorities, life gets in the way. But once I retired and once we got into the lockdown, I was like, I've got all this time on my hands and I can't go anywhere. What am I going to do? I'm going to pick the hobby up again. So that's when I got back into it and discovered the Bury Radio Society, the club that we meet at, and here I am. So this particular talk, you might think there's not much to say about Earth, really. How can anybody talk on this subject for 20 minutes? But the thing is, there's as many opinions about Earth and bonding, especially when it comes to amateur radio circles and transmission, as people have noses. If you look on the internet, you'll see YouTube videos about it, you'll see articles about it, you'll even see things like the RSGB talk about it occasionally. And to be quite honest, quite a lot of what's said out there, I'd say about 33% of it is absolute rot. So we down at the Bury Club, we have quite a lot of M7s who are getting started in the hobby, and they want grounding in things. There's people who want to see the intentional there, see what I did there? There's quite a few of them want to go for the intermediate, and they came asking questions about this. You know, I want to get on HF. Do I need an earth? How many earth spikes do I need to hammer in? Should I connect to my water pipe? And you know, the more you start to think about it and try and answer those questions, the more you realize the answer is, well, it actually all depends. So this talk kind of came out of reading some of the stuff that I read that I thought this is just blatantly wrong and is misleading people. So don't expect loads of answers either in this talk. Hopefully, what I'm going to do is prompt a lot of questions and get you to think about what you want to do, why you want to do it, what situation you're personally in. There's some, you know, in some circumstances, you might go for an Earth system that might make things worse, not better. I've experienced that over the years. And when is Earth not an Earth? There's all these questions that are going to come up. So we're going to kind of get into that, and hopefully it'll give you something to think about. So what is Earth? Let's start there. Well, you're standing on it. You're sitting on it. Earth is the ground. It's the general mass of the planet that we're all inhabiting. Some people see Earth as the third terminal in a mains plug. They think of Earth in terms of the electrical connotations of it, you know, the electrical safety side of it. You know, you've got live, you've got neutral, you've got Earth. Everybody knows you've got to have Earth because it's for safety. Some other people think, you know, Earth is to do with RF transmission. If you don't have an Earth, you can't transmit. There's the first little example of some rot that's been talked. So what exactly is Earth? Why do we have this concept of Earth? Why is it important? Why do people go on about it? Why does it matter? Well, the first thing to think about is, put very simply, Earth is a reference point. That's a key thing. It's a reference point. If you think of making a voltage measurement, you always make a voltage measurement across something or relative to somewhere. And the one thing that all of us have in common, no matter where we are on this planet, is Earth potential. So you begin to see why Earth is very useful. It's a great reference point. So this is sounding very useful. Why is it useful? Well, for a start, it's good for electrical safety purposes. So let's go there for a few moments. Think about that. I might be teaching you to suck eggs here, but for those who've never experienced this before, this graphic shows what happens to people when there's an earth fault and there is no earth connection on a domestic appliance. So basically the live wire connects to the case of the appliance, the poor man touches the cooker or the fridge or whatever it is, and his eyes light up because he's standing on earth, and the supply at the generator end or the power station end or the substation is connected to earth. So there's a fault path down through his body. I don't like where the path is actually going either. That must be quite painful, but shocking, perfectly, yeah. So there's a fault current, but it's worth noticing on that diagram, the reason that the man is suffering is actually because there's an earth connection. Ooh. So earth is not all good. No, he's connected to earth and he's suffering because there is an earth. We get round that in electrical supply terms by obviously making an earth connection to the chassis or the cabinet of the unit. Thereby, we provide a very low resistance, low impedance path to earth so that the voltage drop between earth and the cabinet is very low. So now he's only across a very low voltage. And the other idea is a very large current will flow as a result of that. And hopefully the fuse, which we haven't shown in the line here, will blow, turn the power off, and the man's eyes don't light up any longer. So that's a good thing. So this is wonderful, much to be encouraged, but in amateur radio terms, there could be a hidden pitfall here, which you may not have thought about. And that is if you have a particular type of supply in your house. Now, I'm not an electrician. I'm not a professional electrician. So if there are any professional electricians in here, they'll be able to give you lots more information about this after the meeting. But this particular system that the electricians call TNCS, which I'm told the T stands for terror, which is earth. The N stands for neutral. The C is combined, and then the S means they separate them again. So basically what that's saying is, at the generator end, you don't have an earth connection, you have a PEN, protective earth and neutral. So the earth and the neutral are combined there. And when it comes into your house, they break it out again and give you a neutral connection and a separate earth connection. So as far as you're concerned, when you look in your meter cupboard, you think this is normal. I have an earth wire, but you don't actually have an earth wire. It's actually fed through the neutral from the supply. The reason they do this, and it's more and more common in new build properties, is because it's cheaper and easier to put in. It saves them money. But what you have along the run of that neutral between your house and going back to the various areas, the substations and things, is multiple earth connections on the neutral line. Hence its other name, PME, protective multiple earthing. Well, what's the point of all this, you may say? Well, let's suppose you decide to go out into your back garden and you hammer in a ruddy grey earth spike because somebody has told you you've got to have an earth connection, otherwise your HF radio is not going to work very quickly or very well. And then you decide, well, for safety's sake, I ought to bond that to the rest of my electrical installation. So you connect it to the earthing terminal in your house. Okay, no, nothing bad there particularly. Or maybe you have a metal tower in your back garden. You earth that and you decide for safety's sake, you'll connect that and bond that to your electrical installation as well. Well, normally there won't be a problem, but if there's ever a fault on the supply, yeah, and that earth connection on the neutral link disappears, where's the earth going to go? There is no earth. And don't forget, this is just showing one house. This could be a street full of houses all connected in the same way. There could be a workshop down the road. There could be a supermarket. All of those now don't have any earth connection. Oh, excuse me. Yes, they do. All the way through your ham shack, through your radio equipment, through that piece of RG58 that's connecting out, through your earth spike that you put in. The return connection for all of those 20 properties, plus a small workshop, plus a supermarket, is now flowing through your ham shack. Don't laugh, it's very rare, but it has been known to happen. And it will destroy your gear and probably set fire to a few things in your house. So, don't just assume the right thing to do in all circumstances is go and hammer a pole in the back garden and connect it up to your electrical supply. If you have this earthing system in your house, or you're at all think there's a shade of a possibility you might do, before you go doing anything like that, please go and talk to a proper electrician and get some advice on it. So there's one little thing they don't tell you about. Now, I've got a document on that, which I'll share with you at the end if you want to look up about it, produced by the RSGB, no less, which goes into lots of detail on that. But if that's your situation, that document will help you. So earth can be useful for electrical safety, and you should always have the electrical earth. I've known people who have weird things happening in their radio stations. One of the bad pieces of advice that people mention is just lift the earth. Do not lift the earth. Do not disconnect the earth in your main supply. Don't do it. It's very, very bad. Keep your earth connection. Another reason for earth is for lightning protection, static discharge. If you've got aerials up in the air, you've got things like, you know, metal towers and stuff like that. You've got a beam on the top. You might be the tallest thing in the neighborhood. You might be attracting all that lightning. So, you know, tall buildings, they have lightning arresters on them, which are basically spikes on the top and a very big copper strap down the side connected to something in the ground. It's an earth connection. It's going to give the lightning a safe place to go. Better it goes through there, better it burns up some cables in your static bleed system than it goes through your 1,000-pound transceiver and destroys it. So again, another good reason to have earth. Static, it can be a problem. Even if you're not going to get hit by lightning, range static on your aerial can make an awful lot of noise on the HF bands. And if you've got a system for bleeding that off, all to the good. There's loads of different ways of doing it. This shows just one. You can get these surge arresters. You can buy them on eBay and stuff. The cheap ones are basically just a tiny little spark gap. So if you get a high voltage, it'll spark across that and go to earth. The better ones have like a neon bulb type thing in them, a discharge tube in them. You can do things like a quarter wave stub. So you short it at one end, it reflects and it becomes an open circuit at the other end. So you can actually have a DC earth on your aerial where it's not an RF earth. We'll look at that later. So different things you can do. So we like earth. Do we all like earth so far? Don't forget, we haven't covered the difficult bit yet. So earth's useful for electrical safety. It's good for lightning protection. It's good for static discharge. We like earth, but is it useful when we want to transmit? Well, maybe it is and maybe it isn't. Let's think about it a little bit. This is where we start to get into some of the rubbish that's taught. So we'll see about this, okay? I've got an FT991A at home in my garage, and that's a picture of the back panel of an FT991A. And almost every rig, every HF rig, and some of the others that you'll find, has that little wing nut on it, ground post, or something like that they call it, earth connection. And there's an extract from the manual for my 991A, and this is what it says. The FT991A transceiver, like any other HF communications apparatus, requires, I've underlined it and I've put it in red. The manufacturer of this radio says it's mandatory, requires an effective ground system for maximum electrical safety. What? Didn't we just discuss that? That might not be a good thing to do in all circumstances. And best communications effectiveness. Really? You sure? So you're telling me that if I don't connect an earth pole to that ground lug, I'm not going to be able to get out on HF? Really? Is this the truth? I've got another one for you. Where's this other quote? Here we go. I need to take my glasses off here to read it. TS520, I've got one of those at home as well. Nice old rig. Let's go old, just in case Yaesu in recent years are getting a bit too crotchety. The TS520 manual says, select a good effective ground for installation and then connect an earthing wire to the backside of ground terminal. Obviously translated from the Japanese. Use a heavy earth line as big and short as possible for most effective operation. So the manufacturers are kind of telling us here that this is mandatory. And you talk to a lot of people who are giving advice to new licensees. they'll all say, oh yeah, you've got to have an earth. Well, why do I need an earth? Well, you just do. Well, why do we need an earth? Do we really need an earth? You know, these are good questions to ask. And we're going to cover some of that in a little bit here. For example, just to get you thinking. So if I use my FT991A, as I do, into a 2-meter collinear on my chimney, if I don't have anything connected to that ground terminal, I'm not going to be able to get out on 2 meters. Well, in fairness, it did say HF transceiver. But then again, I've got an end-fed half wave down my garden. I don't have an earth connection. There's nothing connected to that post at all. I also don't have a counterpoise, and I've got DXCC. I'm obviously doing something right, but I don't have an earth connection. Who's lying? Are they wrong? Are they right? You know, these are the questions that come up, and this is why it's not quite as cut and dried as we might think. How does a radio work on a plane? How do the pilots manage to transmit to the ground control people? Where's the earth connection? You go out mobile, you stick a mag mount on the top of your car. Fair enough, using the car as a ground plane, but you're insulated from earth by 4 rubber tires. You know, the more you think about it, the more ridiculous this actually is. And yes, you can go out mobile on HF with no earth, with your vehicle insulated from earth by 4 rubber tires, and you can work to America. So do we really need an earth on that terminal? Well, why does all this confusion occur? That's a good question to ask. Why do the manuals and many so-called experts seem to be saying that you absolutely have got to have an earth connection, when in reality, common sense tells you might not need one? Well, I think there's 2 issues that's going on here. Number one is that this term earth, as we've seen, can mean different things to different people. And the terms tend to get used interchangeably. And people, when they're writing articles, they can tend to mix them up. And worse than that, people who don't have a lot of experience when they're reading the article, they've got an idea of what earth is in their mind. That may not be the same thing that was in the mind of the person who wrote it, so they interpret it wrong. And herein lies a lot of the confusion. So that's one thing. I mean, there's electrical ground, you know, there's lightning protection ground, and then there's RF ground for transmitting purposes, which is which, you know. And the second thing is, when we're talking about communications ground or RF ground, DC principles are going out the window. Now we're not talking about DC, we're not talking about a simple low resistance connection to the mass of Earth or low impedance at 50 hertz, which is all the electricians care about. We're talking about megahertz here. You know, a piece of cable behaves completely differently at those frequencies. And what you think is actually connected to Earth may be anything but. So simple rules don't apply. You've got to know something about the aerials that you're using, why you're using them, how they work, what you want to achieve, what the setup of your station is. And then you can decide what is the appropriate thing to do. It may be something, it may be nothing. You just need to figure that out. So like I said, this will raise more questions than it will give you answers, but that's a good thing. Get you thinking. So there's some situations where if you put in an earth, an RF earth, a transmitting earth, make your life worse, not better. So let's begin to look at some issues here. Suppose you live on the 2nd floor of a block of flats or something. I know somebody who does this. There's a particular amateur who comes to our club, and he lives on the 2nd floor. And he had an earth connection all the way down to a spike buried in the ground. And he had problems with it. And I remember asking him and saying, look, this is probably not the right way to go here. You know, and he was using a long wire, which he was attempting to tune against this earth. And what was worse is we found out after a while that his earth was actually disconnected 2/3 of the way down. It was just floating, which is probably why it started working better, actually. But for example, we obey the letter of what it says in the manual to the T there. We say, I'll connect my ground lug on the back of my transceiver to a nice big ground spike by the shortest possible means that I can with a really big fat cable. Well, you're doing what the manufacturer said, but it might not be a good thing to do. let's say on average, second floor flat, what's that, 30 feet? Maybe. That's interesting. I mean, what's 33? 33 feet is a significant number in amateur radio, isn't it? You've heard about that before. Well, this could be very bad, because if you've got a length of wire at that, what you've effectively got there is around about a quarter wave on 40 meters. So if you're on 40 meters, you've got a quarter wave transformer there instead of an earth lead. If the bottom end of it is connected at 0 volts because you've connected it to a big spike in the ground, what does a quarter wave transformer do? If you have a short at one end, you have an open circuit at the other. If you have a very low impedance at one end, you have a very high impedance at this end. If that end is a current point, what's that end going to be? It's going to be a voltage point. Instead of an earth connection, you've actually put a high voltage on the case of all your equipment in your shack when you go on that particular frequency. That's not what you wanted at all. But you did what the manufacturer said, so it must be all right, mustn't it? Well, no, not really. You'd be far better to actually disconnect it, and then what you've got is a quarter wave counterpoise, which is actually going to work properly, because the free end floating about just above your rose bush will be a high voltage point, and you'll have a low voltage point at the case of your rig, which is what you actually wanted in the first place. So this brings out a very important point here, is that when you come to RF, Earth is actually quite frequency dependent. What works on one band, on one frequency, may well be the worst thing in the world on another one. So you want to think about what you're doing. What kind of lengths am I dealing with here? Are there any resonances here? What's going to happen? You know, we've got a slide on counterpoises in a little bit later, so I won't preempt myself, but you might want multiple ones. Well, if you've got that kind of problem, RF in the shack, we call it, yeah? Well, some of the symptoms of that, I wonder if you've had any of these, you know, things like microphone bites. I've experienced that. I used to have when I was a young, foolish teenager, didn't know what I was doing properly. I had a microphone and it had a metal mesh on it. And I used to wonder why I used to get like tingles on my lips when I was operating on certain frequencies. It's because there was RF on the case of my equipment. Weird things can happen. You know, meters can move on their own. Digital circuitry in your shack can malfunction. You can be getting noise coming out of your PC speakers when you transmit on certain bands. If you're trying to do things like FT8, your PC can go berserk and refuse to function. You know, SWR meters can give weird readings. Things like that can happen. There's a whole litany of them. I used to work, as I said, as a BBC transmitter engineer. There was a very famous one. I used to work at the Moorside Edge station up on the hills there by Huddersfield. And that was, I think it was about 150 kilowatts medium wave output. And in one of the rooms on the second floor there was a water drain pipe that came down off the roof, and it went all the way down through the building and went into the ground. And next to it, about a meter away, there was a 13 amp socket on the wall. And they had a little 60-watt bulb permanently connected between the case of this 13 amp socket and the water pipe. And it glowed 24 hours a day, 7 days a week. So weird things can happen. Weird things can happen. I wish I'd taken a picture of that, but that was before the days of digital cameras. I'd have loved that one, but I remember it forever. So best practices, some answers. Let's give you at least something to take home with you. You might be able to practically use. First question I would ask is, do I really need an earth at all? And I think the answer to that boils down to, depends what aerial you've got. Because if you've got any kind of a balanced aerial, like a dipole, for example, I mean, that's balanced with respect to earth. Why do you need an earth connection? You know, what is it going to do? You can disconnect your earth connection and that aerial will still work fine. But if you're going to use a vertical that relies on the ground to give you the half of the radiating image, of course you need an earth, and you need a damn good one. So there's an instant question, you know, what am I running and why am I running it? That's one of the brilliant things about, I mean, dipoles, all right, they're a bit of a pain in the butt, but, you know, things like an end-fed half wave is a dipole fed at one end, if you look at it that way. Do you really need an earth? Depends. Depends how you feed it. Depends, you know, whether you've got a balun up there, current choke, should I say? I'm going to get my words out. I'm going to come to that in a minute as well. So there's different issues here. Do you really need one? Is the first question. And the answer might well be no. And if you don't need one and you know why you don't need one, don't worry about providing one. Your equipment will work fine and everything will be great. And you'll be able to ignore these people who spout nonsense and tell you that you've got to dig up your lawn. Second thing to be aware of, especially if you're running higher power, is ground loops. This is why you really want a single ground point in your station. If you're going to earth things, use a single ground point. Bring your earth cable into your station and whatever it is to some sort of great big block if you can, and just connect individual cables from everything you want to ground to that ground point. Then you'll avoid the situation as up above there. Now, admittedly, when you're only running 10 watts or 50 watts or something, it's not really going to be a very noticeable problem. But if you're a linear chap, like our late treasurer, Stephen G30AG, who used to regularly run like 1.5 kilowatts on the HF bands, you go and look in his shack, and he was very careful about this kind of stuff. Because you can actually, if you've got earth connections there, and earth connections through the coax connecting things together, you can actually end up with circulating currents in those loops there. And that's going to cause problems, because every time you've got a current circulating, it's generating a magnetic field. It's going to induce another current into something else somewhere else. And worse still, those currents are flowing through the cases of equipment. Occasionally, if you haven't thought it out, it may be flowing through wires in the equipment and along traces on a PCB to get to somewhere else. So you're going to get weird things happening. So try and think about using a star point and eliminating earth loops, especially if you're running higher power. It's always a good thing. We mentioned ferrite chokes, current balance. Here's another one. Because obviously, even if you're running a balanced aerial, you can still, if you're feeding it with an unbalanced feeder, you can still have those third leg currents coming down the outside of the coax. And again, that can get back into your shack. So you've got an RF potential, and depending on the length of that feed line, depends on the frequency you're using, depends on what kind of RF potential you're going to be experiencing on the cases of that equipment. And no, just running a 30-foot cable down the road into a spike is probably not going to make it better. You're just tuning the thing. Better to eliminate the problem at source. Use a current balun up at your feed point or close to it, maybe another one. I just use one personally where it comes into the shack. Can't be bothered to put one up at the top. I tried it, it got full of rain and it got ruined. So I gave up on it and just thought I'll just have one at the bottom. And it works okay. Another thing that you want to be aware of is your main supply coming in. So if you think about it, the earth is connected to the case of your rig, through the outer of your coax, through your tuner, it's connected to that coax all the way. So if you've got noise and muck and switch mode power supplies and goodness knows how many computers and other RF generating filth in your house or your neighborhood, a lot of that is going to be impressed on the earth lead. You're going to actually have mush coming up through your earth, and you're connecting it onto the outer of that coax, which is then inducing noise back into your receiver and giving you a higher noise floor than you need. Damn good idea to think about a mains filter and make it a three-way one. Don't just filter the live and neutral, filter the earth. One of the best ways I've seen to do it is this guy, GM3SEK, and I'll give you a link to his stuff at the end. Look him up on the internet. He's got some, he did a video for the RSGB, which is on their website. Very good watch. He's also got a couple of documents out on the internet about this, and he tells you how to build this filter, and it's basically a docking grade ferrite core, and you take your live and neutral and earth wires and you just wind them through as if you were building a coax choke balun. You're winding your coax around it. You don't, you wind your mains cable around this thing, and because it's filtering the live, the neutral and the earth, it's taking away anything common mode on all of those, and the difference is quite spectacular. I'm going to do this myself. I haven't done it yet because I'm hoping to move out of my frigid garage and actually get a room in the house. And if and when I do, I'll be doing this, but I'm not going to do it now because I'm in temporary accommodation. So, so there's another good thing to try. We mentioned counterpoises earlier. Excuse my throat. I'm not used to talking so much. There's just the diagram we saw before, but with no nasty earth connection on the bottom. If you're working on the HF bands, you could have a quarter wave on each band. They don't need to be in a spirally pattern like that. You can just have them hanging down somewhere. So if you're in an upstairs room, you could just sling them out the window and let them swing around, or tie them to the drain pipe or something if it's a plastic drain pipe. And if you really want to, you could have a switch at the bottom. So if you want to work on something like 160 meters, where you can't get a full thing out and you actually do want an earth, because the length is not significant in terms of the wavelength you're on, then you could close that switch or have a relay to close it or something. So you've got a nice flexible earth system there. That's a good solution for things like that if you're in an upstairs room. Also, don't forget, you know, like a quarter wavelength is the same as a 3/4 wavelength. So you can mix and match here. You could do the same thing as you can with aerials. If you can't get the full length, you could always put a loading coil on. In fact, you can buy quite expensively a little thing, a magic artificial earth thing from MFJ, which is basically just tuning a counterpoise. You could build that yourself and do this. So the thing is, it's not the physical length of it, it's the electrical length of it that you're interested in relative to the frequency you're working on. So there's another thing to think about. Here's a nice old one. This is a weird thing, this is. I found this in, there's a document I'm going to share with you in a few moments, which describes this. And this is something from like the early days of amateur radio, when they were saying, oh, well, if you've got this long thing here, you can do this weird grounding thing where you actually use coax for your earthing lead, and you put a little capacitor in there. And what you're basically doing is you're nulling out the inductive reactance of that earth connection. And so it appears as if it's just a dead short to ground, even if it's like 30 foot long. So there's another interesting little thing. I've forgotten the actual technical name of it, but there's a paper on that I can give you access to afterwards. And that's another way of getting away with it if you're in an upstairs room. And I actually saw a video on YouTube by somebody who actually built that. And he was like, this is never going to work. This is a load of moonshine, this thing. And he actually built the thing and put it in, and he was gobsmacked that it actually did work, and it worked very well. So I've never tried it, but there you go, something to wet your whistle. So we've almost finished here. Some resources I promised you. GM3SEK, he's got a technical blog you can look up there, and he has some information on there, including on how to build that mains filter and some other stuff. He's pretty good on his electromagnetic interference prevention and stuff like that. So if you've got interference problems, have a look at his stuff. And that video is called Clean Up Your Shack 2019. Very, very good video. And I believe you can find it on the RSGB website if you dig back far enough. Well worth a watch. There's another document here by Flex Radio Help Desk. That's available on the internet. If you just search for that title, you'll come up with quite a lengthy, meaty document that actually discusses that weird earthing arrangement that I've shown you in there, and the counterpoise stuff. In fact, I'm not going to admit that some of the diagrams I showed you I actually nicked from that publication, but there you go. And there's also an RSGB leaflet, EMC07, Earthing and the Radio Amateur, which deals particularly with that PME earthing peril that I mentioned to you about, and gives you a lot more technical information about that than I've gone into. And so they tell you about, they explain in great detail how it works and what the particular circumstances are in which you need to seek help. So that's about all I've got to say about Earth, and I hope we're all down to earth. So I'll throw it open if anybody's got any questions. I'm not saying I can answer them, but I'll have a go. Over to
On
you.
that transceiver,
Yeah,
pretty sure it was connected to line music. But Morse, I'm sure that right, they're not mains, they're not got built-in names, so
They
they're
haven't.
all connected to a PSU.
yes,
So they're not actually connected to the electrical, I think, of the house, are you?
are you not? Keep thinking.
I think the problem is there's some power units.
Most power units, I would say.
There are odd ones that I've come across.
Yeah.
The neutral, because if you got the
Yeah.
negative, it's
The negative line is usually connected to the negative output of the supply, and for safety purposes, they connect that terminal to the case of the unit, which of course is connected to the earth pin of the 3-pin plug. So even though your transceiver's powered on 13.8 volts, you've still got that continuity through the black lead. So
and
yeah.
And if you're using the USB, of course, you've got
Through the
same-
shield of the
same
USB cable.
USB,
yeah,
which is difficult then not to get the loops.
yeah, yeah.
When did PME come around?
Oh.
Seventies.
Yeah.
70s.
Well, our house was built in, I think, around the seventies, and their PME. And I don't think S is what did you say, the T,
TNCS.
yeah, I think the S is for shite.
The technical side.
Yeah, well,
It seems to be like.
yeah, there you have it, ladies and gentlemen.
I mean, after now I went to the RSGB guys, but that, no, well, the issues are that in our region, they refer you to, electricity northwest. And I think if we went on car park now and got one of kids would know as much as electricity northwest. That was my experience, that like you talk to them and it's just like, oh, nobody's ever asked us that before.
Yeah,
And that was the downside.
yeah. It is a surprisingly grey area, and I know a couple of professional electricians, but they're professional electricians in the state of they'll come in and wire things up in your house, but do they have the theoretical background to understand this stuff and the implications of doing something slightly weird, which is what we're talking about here? You know, if I want to put an earth spike in my garden, how do I isolate that from the electrical mains, given that I'm going to connect it to the back of my transceiver, which connects through this black lead in my 13.8 to my house earth? You know, you see the problem start to develop. So you need a bit of careful thinking.
Yeah, I mean, Big Star, it's, for example, like I asked my mate who was NIC registered, but also had a background in telecoms, and he was like, about that.
Yeah.
So, and then obviously, you know, he was still current to the latest amendment to it, or whatever. So, if you're lucky, you can find someone who's really au fait with.
Yeah.
Not just with the non-saying really.
Yeah, well, that RSGB document is pretty good. And if you're all worried about that kind of thing, read that first. And if you're an RSGB member, go back to their technical department and say, hey, I need more help with this because this situation pertains to me, and make them earn the membership fee that they're charging you, and they'll help you.
But to answer your question, to land its hours were 70 and they are PME.
Yeah, and I've come across another one that I do is I convert a lot of server power supplies for high current use for 13.8. It's another little pet project of mine. Almost every single one of them is connected through from the negative terminal to the case. If you want to actually have it lifted and isolated, you've got to do it yourself. And I think I've only ever come across one commercially sold radio power supply that was actually isolated. All the others are just earthed, because it's easier for them to design it and build it that way. Why would they not? Well, that's made it go quiet.
Any Zoom questions? So,
Nothing more. Anybody else in?
Is there anybody there?
Well, I've got a question if no one's, I've done to
Go ahead.
I play around with AC/DC radios, not
Yeah.
music. And generally, for safety's sake, I run them on 110 with an isolating transformer. And I have had a go with taking one side of my isolating transformer output down to the neutral. So in other words, making like a neutral chassis unit, or flipped it over to live, and it makes not a bit of difference, provided you don't touch the chassis, whether you've got the chassis floating or tied to either of the 2 points.
Yes, I do a bit of that kind of dabbling myself. There's 2 ways of doing that on the what they used to call the live chassis sets. One of them actually, they just give up on the whole equation, and literally they connect the chassis to one side of the main supply. It's just connected and that's it. And as you said, rightly said, it just depends which way around you put the mains plug. And the more worrying thing is these are all old American sets usually, where the mains plug is completely reversible. So if you put it in the wrong way, your chassis is live or hot, as the Americans say. The other way, and I've got a radio where they do this, is they actually bring the live goes into the usual place, the neutral comes in, goes to a tag strip point inside the chassis that's not earthed, and they use that as the electrical earth for everything, the 0 volts point, and then they have a safety capacitor between that and the physical chassis. So at least there is a semblance of isolation there. So there's 2 ways of doing it. But yeah, if you're dealing with anything that doesn't have a mains transformer in it, the reason you're still alive is because you're a wise man and you use an isolating transformer on your bench. I've got two benches, and both of them have got an isolating transformer on for exactly that purpose, because I enjoy being alive and I want to stay that way. The other thing people don't think about is if you're trying to fault find on a switch mode power supply, for example, or a set like that, where things aren't actually isolated. Yeah, you've got a scope, for example. The scope, the case of your scope is going to be connected to earth for safety purposes. So the outer of the BNC that goes to your scope probe is connected to earth. So the little crocodile clip on the wimpy little bit of cable is connected to earth. And you decide you'd like to measure the switching waveform in a switch mode power supply on the input side, which is connected to the mains. And so you click that little probe on and you wonder why there's a really great bang when your scope goes up in flames and your piece of cable disappears.
The old Dodge was to disconnect the earth connection.
Yeah, the old Dodge was to disconnect the earth connection, and here we come full circle. People who don't know what they're doing would say, yeah, fix it by disconnecting the earth, make everything more unsafe, and you at least you can make this measurement and take your life in your hands, or just get an isolating transformer and solve the problem. Because the whole point about that is, if you remember that diagram we saw of the incoming mains, the problem is that the neutral is connected to earth at the supply point. So if you break that with a transformer and you don't connect the secondary output of your transformer to earth, you eliminate that problem. Take away that earth connection, you take away the shock hazard. Yeah, you might still get a little bit of a tingle off it, just through capacitance and stuff like that, but it's not going to make your eyes light up. So yeah, an isolating transformer is a good thing. It wasn't exactly in the scope of the talk, but it is now. So, anybody else with anything?
Just going back to basics.
Yes.
And we're talking foundation level here. You've got a transceiver,
Yeah.
a power supply, and an ATU, and a simple aerial. How do we look at those connections on the back of those units? Do we run a wire from the terminals on the back between each one?
In terms of what, the aerial?
Well, we use the connection we have to run transceiver to connect an earth point to the ATU, and then also to the power supply.
Yeah, if you're going back to, can we get back to that diagram? I wonder. Here we go. You've already got a connection through there on the outer sheath of the coax, remember. It's the second one when we start to introduce an earth bus, if you like, that's going to cause those circulating currents. So you could use a star point earth if you wanted to actually have an RF earth on all those devices. But as we said, you might not actually need one. It depends on your aerial system. It depends on what you're doing. And to be honest, you're unlikely at foundation level to get a problem on 10 watts. I don't think you'd notice a difference one way or another. It's mainly for when you're running higher power. I think it comes into it. But you can get weird stuff happening, like the RF being induced back into your transceiver, people complaining, your modulation sounds awful, and you can never figure out why. You think there's something wrong with your microphone, when actually the problem is induced muck due to circulating currents. So weird things can happen.
On figure 2, haven't you got ground loops in between everything, because you've got coax connections between each of the little black boxes?
Yeah, that's exactly where the loop is occurring.
Yeah, but in figure 2, because
Here.
you've actually got 2 connections between each box all the way along. What you really want is a single ground point on the last unit and get rid of the others, and then you have actually got you've not got any earth loops from the first, second, and third units.
Yeah, that will be another equally valid way of doing it.
But isn't that then the right way? Because you have got earth loops, as the diagram is shown on figure 2 at the moment.
I think the question is how long these are, because this is assuming that single ground point there is an absolutely solid fundamental earth connection. I think that's what the diagram's trying to show. And rather than having a long sort of daisy chain type of affair, you're bringing everything back to a single point. It's the same thing as if you're building an audio amplifier or something. You'll always find that the best ones have a single star earth point inside. They don't just connect to earth at multiple points. They bring it back to a great big solar tag, and loads of things go back to it. Just try and eliminate the potential difference. Because if you've got a current flowing in that, you've got a potential difference across it, and those things are not at the same potential immediately. Whereas here, you're kind of eliminating that because everything is pulled down to a single point of earth. They're all at the same
But
potential.
through the coax between each unit, you've got an earth that's flowing.
Yes.
So you're putting parallel paths in by putting the supposed single ground point from the far left, the next one, and the next one, and the next one. I know everything's frequency dependent.
Yeah.
And earths are completely relative, but I work in audio myself, or I did till I retired, and you know that is a classic hum causing problem by doing it that way.
Yeah.
You have to keep the actual leads as absolutely short as possible.
Yeah, which is what you want.
You know, the lengths of the frequencies that you're working on, and it's that single point idea. I mean, perhaps at the end, it's probably not a great way of doing it, really.
Yeah.
So you keep trying to keep the things as short as possible.
I think also the coax system that we have is not reliable. The PL259 is not a reliable connector. So to get the continuity absolutely perfect, it's going to be a bit hit and miss, isn't it?
Yeah.
And reliable to is liable to.
Some of these 259s that you buy now for they're absolutely garbage.
Yeah.
You know, when you actually look at the threads, you screw it onto. It's just they're not even tight. A lot of them. They're just.
Yeah.
In fact, when you think you've tightened them up, you can just rock them, and they're not even they're garbage.
Yeah, I've got one in my shack right now that's exactly like that I ought to replace, and I keep ignoring it and just tightening it up, hoping it'll go away, and it never does.
So you'd have a problem there on that top line there. If just say, for instance, you know, between your 100-watt transceiver or your amplifier and your tuner, if you've got like a coax connection and it's not actually fast and it's not properly screwed on because you think it might be and it isn't, then you've got a real problem because you RF wise, you know, you're losing your connection, aren't you?
Yeah. If you want to know more about this ground loop thing, that document that I referred you to at the end, that paradigms and whatever it was, that's multiple page document, and they go into this in a lot of detail. So there's more information about that in there. But no, I agree with you. If you can actually just have a single earth connection from every single thing, you're doing it the best way. Because you eliminate, you can't have a loop when you've only got one connection. But I told you this would raise more questions than answers, and that's a good thing.
Just a point that occurred to me when you were talking about isolation names, mains isolators. I took 3 Variacs to the Blackpool Rally, which sold very quickly. They weren't very expensive, but they were good quality old ones. I just hope that they don't feel the buyers that they are a form of isolation, because
They're not. They're definitely not. Yeah. Yeah, a Variac is an auto transformer. We all know what an auto transformer is. The input and the output are electrically connected together. It's not even a transformer. It's just basically a big transformer coil with a wiper on it. Yeah. So no, there is no electrical isolation in a Variac. It's a very useful thing to have on your bench, but it won't give you electrical isolation for safety purposes. So you need an isolating transformer as well if you're going to get into doing anything interesting.
Keep one hand in your pocket.
Yes, that was the other thing. That was always drummed into us.
I've seen one lad who he was into and amplified and all that sort of stuff. Yeah, managed to get his hand on the plate of the transfer of the amp he was building. It was about 2.5 feet, and somehow he managed to then touch the case. You should see it around. It's just it was blown to bits. Very, very bad. It was not the same. It's all. One could have a bit of a laugh. It can be pretty serious if you get it wrong.
Yes, yeah, it can. And as we said, safety is a big part of earthing. So, you know, it deserves some serious thought, more serious thought, I think, than a lot of people give it. And I think especially the biggest enemy is complacency. So people who've been around doing it for an awful long time, like I have, and some of you have, we've survived so far. We know the right corners to cut, and we've always got away with it. But there'll come one day when we might not get away with it. And as they always used to tell us in engineering training in the BBC, death can be fatal. So.
Right, Alan,
Mr. Chairman.
that was fantastic. Yeah. And a big thanks to Alan as well for getting it all together. Thank you very much. Right, well, building up good relations here between Bolton and Bury, aren't we? That was excellent. Thank you very much.
Yeah, you're welcome down at the club anytime, by the way.
Well, we should do a reciprocal talk and all that sort of stuff. But we'll get.
Yeah, if you've got any good talks for us, please have a word, because it falls to me to try and fill the calendar at Bury. So I'll be coming cap in hand if you've got anything.
Not a problem. No problem. Right, anybody got anything to bring up while we're here?
anything from the Zoomers again?